In recent years, due to the internet and mobile revolution, our life has become increasingly convenient, yet the danger of hacking is ever present and rising. Network Intrusion Detection System, NIDS, is a representative network security system that is designed to compare incoming packets against multi-string patterns, IP address, and so on to detect cyber attacks. Existing high-performance NIDSs are generally expensive and mostly hardware-based products. Hardware-based NIDS is expensive because it should be manufactured using hardware for special purposes, yet offers low compatibility, thus entailing high maintenance and upgrading costs. Hermes, jointly developed by NSRI and KAIST, is a software-based network intrusion detection system that offers enhanced performance and resolves the problem of high cost.
You can use Hermes as Network Intrusion Detection System, or NIDS, simply by installing software. In order to achieve high performance, of course you need to have a high-end server, but the price of such hardware is much lower than that of the dedicated hardware-based NIDS. The development speed of commodity hardware is very fast due to constant large demand. The performance of such hardware keeps on improving with a reasonable price tag on it. On the other hand, the development speed of dedicated hardware-based NIDS is very slow, and its high price will not go down dramatically within the next 10 years.
Unlike the exclusive hardware-based NIDS, the existing software-based NIDS, including the representative SNORT, does not offer satisfactory performance. NIDS reads packets in such a way that packets leaving or entering routers are copied into the memory of the system, and the CPU detects intrusions by comparing the multi-string patterns of known malicious codes and the IP addresses of the sources or destinations. General PCAP library-based packet read is to copy packets one by one into the memory, thus increasing the CPU load. And although the CPU has several cores, packets can be transmitted to one CPU core from the network interface card, thereby disabling the high-speed packet handling. Therefore, the packets, when not handled, are discarded as they are. A packet leak occurs. In order to identify malicious packets, packet payload needs to be searched using PCRE pattern matching, which allows a flexible attack pattern expression. However, this requires the comparison of diverse patterns for individual characters, thus increasing the CPU load. Malicious IP detection also requires high-speed performance. However, the existing software-based NIDS adopts the sequential comparison method, which deteriorates the system's performance. The performance of Hermes has been increased by up to 30 times compared with the 1 Gbps performance level of SNORT, providing the parallelism of CPU and GPU of a regular PC and the method of handling multiple packets simultaneously. In order to reduce the CPU load and resolve the packet loss problem, the research team used the packet shader technology. The packet shader, an improved version of the existing high-speed network system driver, puts together multiple packets and copies them by chunk unit, thereby dramatically reducing the count of interruption and memory copying. In addition, with the application of receive-side scaling technology, it distributes a massive amount of traffic into multiple CPU cores equally, thus maximizing the usage of the system's resources. In order to detect intrusions, Hermes executes each intrusion detection thread per CPU core, enabling parallel processing for large volume traffic. Each thread calls out functions based on a chunk unit of multiple packets, thus performing diverse work such as communication with the GPU for multi-string matching using the batch processing method. Using IP reputation and the Berkeley packet filter, the speed of detecting malicious IPs has been dramatically enhanced. In addition, to enhance detection performance, diverse technologies have been adopted, such as the simplification of packet structures for reducing the load, memory copying using the JMalloc library, and support for the NUMA architecture. Notably, this system uses GPU for multi-string and PCRE matching. The GPU, which transmits visual information to the monitor, has many cores and shows excellent performance in simple calculation. For this reason, for multi-string and PCRE matching, the use of GPU guarantees a high speed. Furthermore, in order to improve the detection performance, in the case of PCRE matching, which involves creating a relatively large load, an algorithm that transforms the regular expression detection rule into the string detection rule has been adopted. The excellence of the system has been proven by conducting the 40 Gbps TCP traffic test with the application of the SNORT HTTP detection rules. The performance of Hermes has been shown to be 1.9 to 4.3 times superior to that of Media, which was presented at ACM CCS in 2011. Compared with SNORT, which uses the high-speed packet collection library, PF-Ring, developed by NTOP, the performance of Hermes has been improved by 2.7 to 4.5 times up to 33.2 Gbps. The proposed product can be produced for less than 50% of the cost compared to existing NIDS products, enabling a greater number of corporations and agencies to adopt NIDS and thereby contributing to the realization of a safer internet environment.